So here's my thinking on the AP review number 5. So this question describes a person throwing a toy. The toy has two spheres connected by a string, and it's been thrown as a projectile, so it's been thrown on an angle, and it's traveling through the air with a trajectory, but it's also rotating about its center of mass, and it's rotating counterclockwise. And the first question asks about the horizontal and vertical components of the velocity of that center of mass as it goes through its projectile motion. So I'm thinking about something that looks like this. Here's its trajectory, and the center of mass is going to follow that path. So really the fact that the toy is rotating clockwise doesn't affect the fact that the center of mass will just travel like a projectile. So the horizontal velocity, I would expect a positive value that's not going to change, since moving to the right is a positive direction, and there's no air resistance. There's nothing resisting the motion of the toy, so I would expect no change. The vertical velocity, however, it's moving up, and then it's going to stop moving up at the apex here, the peak, and then it's going to come back down. It's going to decelerate on the way up, and it's going to accelerate on the way down. So I would expect a velocity that is positive. However, it approaches zero with a constant deceleration, and then continues to have a that same acceleration, but again, it's going to speed up as it moves down. And I would expect that at the final time, if it's going to reach the same height that it had started at, then I would expect a speed. Whatever it is here, it's the same here. So I would expect, if this is 3 units above, I would expect 3 units below the origin here. So if it started at 3, it should end at -3. And my graph appears to do that. So that's what I believe the answer to be for the first part, for A. For B, it asks for a free body diagram at the peak. So the toy's at the peak, and they want the forces acting on the left sphere. So I'll draw that here. So if this is our toy and this is our left sphere, then I would expect, again, a force down. So the force due to gravity, but the left sphere also has this string attached to it. So I would expect a tensional force also acting on that left sphere. So I would label that tension. And then the other part of this question wants what would be the forces acting on the center of the string. So now we're looking at the center of mass. So if my dot were the center of mass of my string, I would expect just the force due to gravity. I wouldn't draw a tension force here because the tensional force would be acting on each of the spheres on the end of the string. I wouldn't show a tensional force as part of the string itself. So just one force here. And then so that was B, I and double I. So for triple I, it says when the toy is released, the center of the string is moving with an initial speed of 15 meters per second at an angle of 60 degrees. So the toy was released. So here's our toy. Here's our string. It was released, and it had an angle. Here's our angle. So it was released with a speed of 15 meters per second, and the angle here with the horizontal was 60 degrees. It says calculate the speed of the center of the string at the instant shown above when the center of the string reaches its trajectory, the top of its trajectory. So here. So I guess if it were to go through its projectile motion at the peak, its velocity would be only horizontal. So then whatever horizontal velocity it had initially would be the same as what it has here. So since this is the adjacent side of our vector, I would say we would need to use cosine. So I think cosine of 60 times 15 meters per second is our velocity in the x direction, which I believe that is going to be 7.5 meters per second. So I believe our answer is 7.5 meters per second to the right. And that's it for that shorter FRQ question. So that's number 5. Hopefully that helped.